Güzeldir ya. All right. So the idea is very simple, right? So you can see that we can get to a method perhaps in a few indirections, but we can get to we can check the method dictionary of our object. If not found, we can look at the superclasses method dictionary. If not found, we can find perhaps there is a superclass of that as well. We can find the behavior of that message that way. And you can handle, of course, let's say, overriding or the behavior that may be changed, let's say, in the derived class or the subclass by just putting a new code or new behavior for that part of the same message. So a very, very simple idea. Right. So let's look at encapsulation in Smalltalk. So the first thing is that methods are public. So they are all available to outside. So there are no hidden methods, no protected or let's say public methods or private methods. So they are all public. Now, of course, this may not be as bad because the question of actually perhaps this, let's say, within class specific, let's say, things like methods like, let's say, that you don't want the outside to see, but you want to be able to use within the class is not going to be available here. Right. Because it will make the development, this task quite problematic. Then you have to have, let's say, perhaps two method dictionaries, one a private method dictionary and a public method dictionary, and so forth. So perhaps it can be done, but Smalltalk originally didn't want to have it. The second one is the instance variables. They are hidden. The variables are not available to outside. This is what Alan Kay was saying. He's saying, I don't want anyone to mess up with my internal state. If you open up the variable, you are opening up actually that kind of form that outside people can actually do that. And when they do that, they are actually changing the intended use of that object altogether, right? So this is what this language is saying. Methods or instance variables are hidden. Okay. So this means that it is not visible to other objects unless you actually make it available, meaning you have a method that changes your X or changes your, let's say, instance variable. Again, this is a good idea from the perspective of encapsulation. You say, okay, if you want to do it, if you want your object to change its internal state, make it available or make it through a message itself. Don't do it, let's say, in another way. The user of your object should actually send a message to do the change. So what you are doing is, yes, you are causing, these are kind of the same thing, right? You are saying, okay, I am modifying the state through a function or through a message, and I'm not able to modify it without a message. So what is the difference, or with a message? What is the difference between these two? The difference is in the semantic. And the way that how I can use that semantic, I can say, okay, I don't want my internal state to be messed up. So I will not actually put those messages, put those methods that will actually change that. So that will be possible. If you want them to change it, then you change your semantic a little bit perhaps, but okay, that's up to you. But the language actually enforces this idea, this simple idea. If you want to be changing your internal state, then make it explicit, not implicit. Of course, there is one catch to this one. It says the instance variables can be actually manipulated by the subclass methods. Even though they are not available to outside, so let's say X is not available to me, but these variables, for example, can be manipulated by one of these functions here, one of these methods here. This can happen. So this is a kind of a limitation in establishing invariance. So this is an idea. You must have seen this idea in your data structure classes, perhaps, that sometimes you may want to actually establish an invariant, let's say, thing that neither the, let's say, the object itself or the derived subclasses should be able to change that. So a simple example is that a superclass maintains a sorted list of, let's say, messages with some selector, that assume that, let's say, an insert, and subclass may access that list directly and rearrange that order. All right. So this is not a very, this is a limitation. Okay. In summary, a class creates an object that share methods and pointers, provides pointers to templates, dictionaries, parent class, and so forth. Objects are created by a class, which is another object itself, and it can contain instance variables. Encapsulation works with methods being all public, and instance variables are all hidden. Subtyping is implicit. No static type system here. You cannot actually you cannot define this typing statically. This will happen dynamically. And inheritance is going to be provided for subclasses with self and super relationship. So you have the self being the object itself, the class that actually belongs to the creates an object, and the super is the class that actually does that thing. So in this example here, for this guy, self is going to be this one, and perhaps the super is going to be this one. And this supports single inheritance. You can see that there is only one inheritance here, meaning I cannot actually, I have only one way to define a super, or subclass. There is only one link here. The question of should I actually have multiple links here? And in that case, I can open up, let's say, possibility of what we call multiple inheritance, but original Smalltalk doesn't allow that. Okay, any questions? All right. We're going very fast without questions. Let's look at another instance of a purely dynamic programming language, dynamic lookup programming language, which is called self. So these are also called prototype-based pure object-oriented languages. Again, came from Xerox PARC, and Randall Smith and David Ungaras are the guys that actually developed this. You can think of this as a successor to Smalltalk AD. It came from again, the idea, their motto is the power of simplicity. Everything is kind of simplified in a way that you can use this. If things are simple, its power, it can be powerful, and it will be a power. I mean, if it is doing something, it will be powerful, perhaps. Okay. So this prototype-based programming is simply very actually similar to this idea of everything treated as an object. So you don't have any classes. Okay. So you create objects, and objects inherit directly from other objects through a prototype property. So you build new objects inheriting behavior from the objects that you actually derive from. So this leads to a simple language rules. For example, you don't need to answer the question anymore: is a class an object or not? You don't have a class, and it can also an object can be given. Any object can be given specialized behavior. Okay, for example, you can create an object, specialize an object for debugging versus and debugging purposes, and then you can destroy that, and you can continue with your, let's say, original thing. And it also provides interesting control capabilities, like creating singletons, for example. So you don't, if you don't define so we'll see this example. If let's say, if you have a class, if you have an object, you derive another object from that, and then you say, okay, you disable the copy construct for that, copy semantic for that object. If you don't allow it to be copied, then you are done. You created a singleton, and it can be, let's say, it cannot be recopied or replicated or whatever. You know all these singleton patterns, hopefully. We are talking about only one instance of a class. In this case, the conceptual class. Self doesn't have a class, but you have an object of that concept class, and you don't want to have a multiple copy of it. You have only a single copy of it. And you will need only this copy throughout your system's lifetime. And things like logging and communication databases and so forth would use this singleton pattern. We call also this sometimes pattern. So the question of actually how do you ensure a class has only one instance and can be accessed globally, right? So you can use global variables, which we said, oh, no, not a good idea. So this pattern, I mean, self can actually give us some interesting, again, options for having more control over the instance, and you can also still define context dependency and so forth. All right. So the design goals for self was, first and foremost, conceptual economy. So you want to actually make sure that your concepts are very, very simple, small enough, so that you don't need to spend a lot of, let's say, writing, speaking, talking to explain them. So the idea of treating everything as an object, having no classes, having no variables. This is another thing, that this language doesn't have any variables. Everything is done using messages. This is the first, again, the first design goal. The second design goal, we want to provide some correctness. Objects should seem real. you can have GUI to manipulate objects directly. All right, so nice language. As far as it's successful, is it successful? Even though, I mean, when you see these type of things, self is a carefully designed language, you know what is going to come after this. This is saying that, okay, yeah, it is a good language design and so forth, but it is not very popular. There were no compelling applications of this type of a conceptual economy and correctness till JavaScript. And so this seems that actually this has something to do with internet, but it influenced the development of many object-oriented stuff. Okay. So very simple computational model, enormous advances in compilation techniques, and especially JavaScript, and after that, it also influenced quite a bit of Java. Okay, so basically it's a dynamically typed language. Everything is an object. So when we say dynamically typed, you know what we mean, right? So things are happening, the type definitions and type checks and stuff, the typing system is maintained dynamically. It's not static. It's not, when I look at the code, I cannot actually trace things from one place to another place. It's not static. Everything is an object. All computations are done through messaging, and creation of and initialization of objects are also done through messaging, which is just a cloning of an object. Operations of object, base operations of an object on objects are sending a message to it, adding a new slot, meaning you add new behaviors to that object, you replace old behaviors, and you remove some behaviors. These are the things. The slots are going to be for messages and methods and perhaps also variables here. All right. So objects have named slots like data. Such slots are returned. They return contents upon evaluation, like an instance variable. You have assignments, set the value of an associated slot. Methods contains self code, and then parent is the inherited slot. All right. So let's look at the kind of a comparison, a simple comparison between Smalltalk instances and class and self objects. So if you recall, in a Smalltalk, I have the objects here, which has only a pointer to the class and the instance variables, values for the instance variables. So I have two objects here, and they both point to this class as its instantiator or creator. And then this have, of course, this has methods, a dictionary, as well as templates. And then this guy can, in turn, point to another class and so forth. All right. In the self case, what you do is you start with your object, and then what you do is you add to that. So you have here two objects, perhaps cloned, and these two objects have actually a parent. Okay, it's not actually cloned, it's actually created from this parent. All right. And then this is also derived from another object, perhaps. Okay, so let's look at how it is actually done. to create, okay, let me go back to here. So, so object creation, to create an object, we can copy an old one. We can add a new methods to new methods override existing one, or remove the existing methods. These are also these operations also apply to parent as well, if we actually do this one. So changing the parent pointers, what we can do is we can change this behavior of the parents of that object as well, if you want. So let's see, there is a simple code here. Actually, I'm already getting into, let me see, when did I go from, let's look at how actually JavaScript is very similar to Self, and we may read a little bit easier with JavaScript. So you have a function here, a point function, okay, and then this is where the prototype thing comes in. You have a new to create an object of that function, from that function. And then now you can actually can add properties to that object. This didn't have a color. Now what I'm doing is I'm adding a property, a slot to that object, and setting its value. Now I know that this guy has not just X and XC and YC, it also has color property, or this color property, and they actually changed it. And I can add another one here. I'm adding actually a distance to origin function or method or message. And this is a new function. So I'm adding to this original thing now fourth thing. So these are if you think they're as class instance variables, you have 1, 2, 3 instance variables, and you have an additional function or additional message that this can actually get. Now, of course, now here you can see that I can access it through this, since I know that actually this is now added to this P1 class or P1 object, and this object's let's say class variables or instance variables can be accessed through this dot notation. So what we are doing now is actually we are starting from, let's say, some base, and we are building something on top of it and modifying the behavior and so forth, so that now there is another class actually right now. The first class was this one, and there was an instance of that in P1, and that class had only these two variables. Now, at the end of this code here, I have another class, which is a new concept, but I don't have the class somewhere in there as an entity. It's just a concept, and that concept came around by just me modifying the original concept and adding two new things, two new slots to that particular thing. So this is how actually these prototype-based languages work. And the prototype here is actually this. I'm adding the prototype and new things being added to my my existing object on the fly. And this is done on the fly. This is not a compile time construct. This is a runtime construct. So in JavaScript, this is called prototypes, and every JavaScript object has a prototype. These object literals are linked to object.prototype, otherwise prototype based on a constructor, and so forth. And you can change the JavaScript prototype by the prototype is the prototype property is immutable, and changes to prototype property can be inherited immediately. All right. So you can see that now these type of simple constructs where the object management construction is now actually the concept implementation and instantiation of that concept is not separated here. So the concept is in your mind, which is a class. Class is in your mind. And what you have is only the objects. And the objects actually are keeping the specific concept in implementation as it is. It is real, it is there. Of course, this has some problems, right? So one problem that you can easily see is, so let's look at it here. At the end of the code segment here, if I ask you to describe what your object is doing, or what is the semantic behind that object, you have to look at the code and actually rethink. And you'll be able to answer only by looking at actually what you have done. There is no one place, some code that actually gives you a glimpse of what is happening there. So that abstract thing, the concept itself is not anymore written in a class, but it is actually kept somewhere in your mind. And the actions that you have here defines that concept. So from one perspective, this is very good. This is very simple. You can build very, very flexible. You can do a lot of stuff with this one. And easy, concept-wise is easy. But the things that you are gonna build, and you communicate these things with the user of this particular, let's say, object, is not gonna be there. So the concept of actually user perspective and programmer perspective is gone. Everyone is now almost user and at the same time programmer of that behavior of that class. But you are only operating on the objects, not with classes. You are just modifying objects to create new concepts. All right. Any questions? Of course, we didn't talk about efficiency here. So the question of actually, how am I gonna get, so things are not that difficult. It's very similar to self in that I can, when I come here, for example, I can take this P1 object and I can maintain several things. One is, let's say, a method dictionary type of a thing, or method list of methods. And I can go back and actually modify and check where, if that message is actually is understood by that object. So but to get to, let's say, a few levels up in the hierarchy of these concepts, what you'll have is you'll have these indirections. So they are not going to be very efficient in terms of implementation. So runtime efficiency of these things will be quite bad compared to, let's say, more efficiency oriented languages like C++, for example. Any questions? No questions. All right. Then we are done for today. I'm gonna move on to statically typed object-oriented languages to handle some of the problems that we discussed here, especially efficiency and some other things like, let's say, multiple inheritance and so forth. So we'll continue on Wednesday.